Hello again, I'm Alex from OpenFord, and we continue our deep dive into the EAP 8141 frame transactions. In the previous video, we walked through the high-level design and the basic understanding of the EAP. The last thing we talk about how the layout of the transactions look like. In this video, we will describe the structure of the frames, and we will cover a new opcode. So let's start. So tiny recap. In the end of the video, we end up with the structure of the transaction type 6. So if you didn't watch the previous video, I suggest you to go back and watch this video. So we know that basically the layout of the transaction, we have the chain ID, nonce, sender, and the frames basically. So inside the frame, the structure is the mode, target, and gas limit data for each frame. Okay, great. So let's see what's happened inside the frame basically. So frame, as we said, include mode, target, gas limit, and data. Mode have different three types of mode, so we will cover in a minute. Then the target is a 20-byte address, or if we're not passing nothing, it's null, so it will be tx sender. So basically this setup of the sender from the transaction. Then we have the gas units of this frame. So basically we need to allocate the gas units that basically consume the frame, and data, basically the regular call data that we know that includes the selector and the inputs to execute an instruction in smart contracts. So what basically modes are saying? Let's break down. Okay, so we have the mode 0. It's named default. So the caller is entry point, which is protocol defined address. It's address 0xAA. So basically it could be a precompile. This is a standard EVM call, and basically we can to do the state modification is allowed. Which use cases, for example, this could be for account deployment, post-operation cleanup, or some general setups. Then the second mode is mode 1. It's the verify mode. The caller again is the entry point, same precompile address, but it's execute under the static call, so no state modification allowed basically in this call. And the critical thing that the frame must exit with the new opcode approve. So we will cover soon this opcode. If it's exit with any other way, like for example return or revert or out of the gas, so the entire transaction is invalid. So it's not that basically the frame fails, because we can include in the transaction as many frames we want. Basically we have limit of 1000 frames per transaction. So the whole basically transaction drops, not just the frame. So the important means that verify mode frame either fully validates or transaction never happened. So the verify frames are where the signature verification happen and the authorization also happen. And the last mode is mode 2. Name of the mode is sender. So the caller is tx sender basically itself, that we can see inside the transaction that we are passing here. Okay, so basically the caller is sender. Also, we will talk what the difference between the caller and basically the sender in the context of message sender and tx.origin. So what this mode says, so basically this is how the account executes its intended action. The target contract sees message sender as the account address, but sender frames can only execute after sender was approved, has been set to true by a prior approve. So in the verifier mode, so verify mode, we need to end up, as you remember, with the new opcode approve. So after the verify, we can basically send the mode to sender. So if we will look on the structure that we have of the frames, so technically the first frame should be the verify frame, and then we can basically execute the frame with mode sender. So this is important point to understand about the modes. So the entry point at the address 0xAA is the Ethereum built-in orchestrator for the frames transaction. I think it might have the same design as the ERC4337 entry point contract. When a verify or default frame mode executes, the target contract can check message sender. It's basically the address 0xAA to confirm it's being called by the protocol as part of a real frame transaction, not by some random contract. So basically, if you're familiar with the account abstraction implementation, so inside the account, you basically implement modifier that's validating that the message sender who reaching the account is the entry point address. So this is the thing basically will work in the same design inside the transaction type 6. So here is the important point I think you need to remember and understand very clear. So the tx.origin returns the frame's color, not tx sender. So the tx sender that we have here inside the transaction type 6 here, not inside the frame. Okay, so important to understand that this is like different from the legacy transaction where the tx.origin is always return the EOA basically who initiate this transaction. So it's a very, very different design that we know before. So in default and verify modes, both of the message sender and the tx.origin is the entry point address, the precompiled address 0xAA at the target contract. So if the target calls another contract that inner contract sees message sender, of course it's gonna be like who the last called, but the tx.origin, it's always gonna stay in this mode. It's the entry point address. Here is a little bit tricky. So in the sender mode, both of the message sender and the tx.origin is the tx sender, that basically the sender inside the transaction. So for example, it could be Alice or Bob at the target. If the target calls another contract, so the inner contract will see the message sender, of course, the last caller, and the tx.origin, it will be Alice or Bob, like basically the sender field. Same pattern as legacy transaction, just with Alice being a smart account instead of an EOA. I think this could be a crucial point for the security perspective inside the validation if we are relying on message sender in some contracts. So we must have to understand basically in each mode who gonna be the message sender or the tx.origin. So I think this is you should remember when you will design the next future smart account or any other protocols that basically will rely on the validation of the message sender or tx.origin. Okay, and the next and last thing for this video, I want to cover the new opcode APPROVE. So APPROVE is a new opcode at the heart of the EAP. Is a opcode with value same like as an entry point address, which is nice to remember, I guess. So if we will look on the stack before, so we can see basically that we have a field scope that can allocate three different kind of modes, I would say, but it's not modes. So three different variables. Then length is basically return the data length, and the offset that basically returns the data offset. So it kind of behaves like return opcode. It terminates execution and return data, but it carry on the addition scope of operand that tells the protocol what's being approved. So remember I said that this opcode basically must have end up with the frame mode verify. So basically when we are finishing execute the frame with mode verify, it should exit with this opcode. Okay, so the values here, it's very different from the modes that we know here. Okay, so let's cover these values and basically what it says. So what meaning the values of the scope? So let's start from the scope 0. It's approved execution. So basically you can imagine it's like I approve this account to execute sender frame, like the frame target must equal to be tx sender. So some constraints that you need to remember. Then the scope is value 0x1, so it's approved payment. So basically it's kind of approve gas fees to be deducted from this target. So for example, no target constraint, any contract can volunteer to pay and sponsor this transaction. Scope with value number 2, so it's approve both. So basically approve the payments and approve execution. So it's combine execution and payment in the single call. And the constraint, it's basically the target must equal tx sender. So any scope of value outside of this basically numbers from 0 to 2 cause an exception halt, and basically the transaction becomes invalid. So let's walk through a little bit ordering rules. So basically this is the state machine that governs that approve lifecycle. So initial state, the sender approved is equal to false and the payer approved is equal to false. So inside the approval, the rule 1 is the sender must be approved before payer. If someone calls approve with a value 1, but the sender approved is still false, the frame reverts. So important thing, the frame reverts, not the full transaction reverts. Rule 2 is each type of approval can happen exactly once. So a second execution approval, frame revert, or second payment approval, frame revert. So it means that if we in first frame with mode verify, we approved, for example, with value 2, the scope is 2, so it's basically approving the sender, is approved execution and approved payment. So in the next frame, if we end up in exiting with same opcode, so basically the frame will revert, not the full transaction. Rule 3 is the approve with value 2, applies execution first, then payment. So it's required that the target equal to the tx sender for the execution approval. Then the rule 4, nonce, is incremented when payment is approved, not at the tx start, like the transaction started. Then the rule 5 is gas fee are collected from the payer when the payments is approved. Rule 6, if the pair approved is still false after all frames executed, the transaction is invalid. So basically not one frame is reverted. It's like full transaction reverted. So also the sender before payer rule is critical for sponsorship. It means that the sponsor can inspect the transaction, read sender, check their token balance, verify the frame structure, knowing the sender has already authenticated. So the sponsor is making a payment decision based on the verified identity. So yeah, it's like basically same in the account abstraction in the current design system inside the paymaster contract. You can basically parallel these two things basically as is, that the paymaster, it's kind of the payer, you can say the contract or the account that basically sponsoring the transaction. Some example is in, for example, just imagine in sponsor transaction, the frame 0 is basically the Alice sending verify mode. So inside the verify mode, she calling to this opcode approve, basically to approve execution, let's say approve with scope 0. So now the sender approve field is true. In the next frame, frame 1, is the sponsor verifying frame. So the sponsor's code can safely check if the, for example, Alice token balance an expected frame, like with the second call data. If everything checks out, so the sponsor call approve with scope 1. So basically the sponsor account end up with an exit through this opcode with scope 1 to approve the payment. And then exact moment the Alice nonce is incremented and the gas fees are collected from the sponsor balance. So before, in the first frame, whereas the mode was verify, the nonce is not incremented. So for example, if on the verification phase, the checking, let's say, signature of Alice on behalf of your account, and it's failed, so the nonce not incremented and the gas fee is not collected. So if Alice had not approved execution first, the sponsor account can basically can't end up with approve scope 1. Okay, it's the frame will basically revert. It's not the transaction, the frame will revert. So the protocol enforces basically this order. It's also I think very important to remember. So in this quick video we covered how basically frame look from inside, and we covered the important opcode approve. So in the next video we will continue to deep dive of the AP 8141 and learn new stuff. So see you in the next video. Bye bye.